Two Android distributions, both built by small teams of genuinely committed privacy engineers, both free, both open source, both targeting roughly the same set of Pixel devices, and both claiming to be better than stock Google Android for privacy and security. CalyxOS and GrapheneOS. If you ask the privacy community which one to install, you will get strong opinions in both directions. If you ask the developers of either project, you will get thoughtful answers about the trade-offs their design decisions represent. What I want to do in this video is walk through those trade-offs carefully. Because the choice between these two operating systems is not a choice between good and bad. It is a choice between two different security models that optimize for different threats. And one of those models, in my view, fails at the privacy goal it sets out to achieve in a specific and important way. I will defend that claim with architecture, not with rhetoric. Let me start with what both projects share. Both CalyxOS and GrapheneOS are based on the Android open source project, AOSP, which is the upstream code that Google publishes as the foundation of stock Android. Both projects strip out the proprietary Google Play Services layer that comes bundled with commercial Android devices. Both implement various hardening measures beyond stock AOSP, and both support verified boot, which uses a chain of cryptographic signatures from the bootloader up through the system image to ensure the code running on the device has not been tampered with. Both run on a relatively narrow range of devices, primarily Google Pixel phones, because Pixels are the only mainstream Android devices that allow the bootloader to be unlocked, a custom operating system to be installed, and then the bootloader to be relocked with a custom verified boot signing key. That last capability, relocking the bootloader with custom keys, is essential to the security model. Without it, a device is vulnerable to evil mate attacks, where an attacker with physical access replaces the system image with a compromised version. So far, the two projects are equivalent on the basics. The divergence is in how each project handles the absence of Google Play Services. Google Play Services is a proprietary layer that provides functionality many Android apps depend on. Push notifications through Firebase cloud messaging, location services, in-app purchases, safety net attestation, certain Maps APIs. Many apps refuse to run properly without it. Removing it entirely breaks a significant fraction of the Android app ecosystem, which is a major usability problem for most users. CalyxOS solves this by bundling MicroG, a free software reimplementation of the Play Services API that translates app requests into calls that can be served without Google. MicroG is a real engineering achievement. It allows a large number of apps to run on a Google free system by providing API compatibility without the proprietary implementation underneath. The cost is that MicroG runs with elevated privileges because it has to impersonate Google Play Services to the apps that expect it. MicroG is granted system-level signature spoofing capabilities, which in AOSP security model terms is a significant privilege escalation. GrapheneOS takes a different approach. Instead of replacing Play Services with an open-source re-implementation, GrapheneOS allows you to install Google Play Services as a regular sandboxed application, with no special privileges, no signature spoofing, no system-level access. Apps that need Play Services functionality talk to it through the same restricted APIs that any app uses to talk to any other app. Play Services runs in its own user namespace, subject to the same permission model as any third-party app. If Play Services tries to access something outside its sandbox, it fails, just like any other app would fail. This is the core architectural divergence, and it is where I believe CalyxOS makes a choice that fails at its stated privacy goal in a way that deserves to be examined plainly. Here is the issue. The sandboxed Play Services approach on GrapheneOS means that the system trust boundary is clean. Play Services is a guest. The operating system is the host. The guest runs within the constraints the host imposes, and those constraints are tight. If a Play Services component is compromised, the blast radius is limited to what a normal sandboxed app can access, which is not much. The MicroG approach on CalyxOS blurs that boundary. MicroG needs signature spoofing to work. Signature spoofing means MicroG can present itself to other applications as if it were actually signed by Google, which is required for apps that check signatures to validate their Play Services dependency. Granting signature spoofing capability to any component, even a re-implementation of Play Services, creates a system-level privileged process that runs throughout the device lifecycle. From a security architecture standpoint, this is a compromise. It reduces the integrity of the privilege model. The CalyxOS developers have discussed this trade-off openly, and they have made a defensible engineering argument for why the usability benefit outweighs the security cost for their target users. I disagree with that weighing, but I want to represent it fairly. The second major architectural divergence is in application sandboxing and hardening. GrapheneOS has invested significantly in modifications to the Android runtime to harden against memory corruption exploits. They have implemented a hardened memory allocator, replacing the default Jamalloc implementation with a custom design that resists heap exploitation. They have added per-app permission toggles for things like network access and sensor access, not just the coarse-grained permissions Android provides by default. They have implemented stronger restrictions on how applications can communicate with each other. They have added exec spawning randomization, storage scopes, contact scopes, and a range of other controls that meaningfully narrow the attack surface available to a compromised application. CalyxOS implements some hardening, but substantially less. The project has historically focused more on usability and on shipping a complete privacy-respecting system than on depth of kernel and runtime hardening. This is not a flaw in absolute terms. CalyxOS is still more hardened than stock Android, but relative to GrapheneOS, the depth of the security work is not comparable. For a user whose threat model includes sophisticated targeted attackers, the difference matters. For a user whose threat model is primarily about minimizing data collection by advertisers and Google, the difference matters less, and CalyxOS may be sufficient. Third divergence, default behaviors. CalyxOS ships with a number of privacy-oriented defaults. It includes the F-Droid App Store pre-installed. It includes Datura Firewall, a front end for managing app network access. It routes DNS traffic through a privacy-respecting resolver by default. These defaults help users who do not want to manually configure a privacy-respecting system achieve reasonable privacy out of the box. GrapheneOS ships with fewer pre-installed applications and fewer defaults. The philosophy is to provide a secure, minimal base that users configure to their preferences. This is less friendly for a user who wants things just to work, but it is more consistent with a security philosophy that treats every bundled component as an attack surface. Fewer pre-installed applications means fewer places where a vulnerability could compromise the system. Fourth divergence, which is more subtle. Update cadence and security response. Both projects track upstream Android security patches. GrapheneOS tends to ship security updates faster than CalyxOS in most cases, sometimes within hours of upstream releases. CalyxOS has historically lagged by days to weeks. For a serious threat, model the gap between a vulnerability being disclosed and a patch reaching your device is a critical window, and faster is better. Neither project is slow by industry standards. Both are faster than most commercial Android OEMs, but GrapheneOS is faster than CalyxOS, and that difference compounds over time. Now, the fair defense of CalyxOS. The project is not trying to be the maximum security operating system. It is trying to be a privacy-respecting Android that normal people can actually use without breaking the apps they depend on. If you are a journalist whose primary threat is corporate surveillance and data brokers, and you need to use banking apps and rideshare apps and messaging apps that depend on Play Services functionality, CalyxOS with Micro G may provide a usable experience where GrapheneOS with Sandboxed Play Services creates friction that pushes you back to stock Android. A privacy operating system you actually use is better than a more secure one you abandon. That argument has genuine weight. I am not dismissing it. The question is whether the usability advantage is large enough to justify the architectural compromise, and whether CalyxOS's framing of its own privacy properties accurately communicates the trade-off to users. My concern is that many users install CalyxOS believing they are getting GrapheneOS-level privacy with better usability, which is not what they are getting. They are getting a legitimately improved privacy posture over stock Android, with a security architecture that is weaker than GrapheneOS in specific documented ways. And that distinction is not always communicated clearly in the decision materials that users encounter before they install. Where does this leave someone trying to choose? I would put it this way. If your threat model is primarily privacy from data brokers, advertisers, and corporate surveillance, and your constraint is that you need most apps to work without manual effort, CalyxOS is a reasonable choice, and it is a meaningful upgrade over stock Android. It is not the wrong answer for that user. If your threat model includes more sophisticated adversaries, if you care about the depth of the security boundary around Play Services functionality, if you want the strongest available protection against targeted exploitation of a mobile device, GrapheneOS is the stronger choice. The architectural decisions are more aligned with the threat model. The reason I said at the start that one of these operating systems fails at a privacy goal is specifically this. If you define privacy in the narrow sense of not sending data to Google, both operating systems improve on stock Android. But privacy and security are entangled. An operating system that has a weaker security architecture is an operating system in which a compromise can have larger privacy consequences because an attacker who breaks into the system can exfiltrate more data before being stopped. CalyxOS's micro-G-based model, with its signature spoofing privileges, creates a larger potential blast radius than GrapheneOS's sandboxed Play Services model. That larger blast radius is a privacy risk, even if the goal of reducing direct Google contact is partially achieved. In the modern threat environment, where mobile-targeted malware, like the Pegasus spyware, has been documented deploying zero-day exploits against iOS and Android, the security depth of your operating system is a direct input to your actual privacy, not a separate concern. Neither project is run by bad actors. The CalyxOS team is dedicated, transparent about their design decisions, and responsive to criticism. The GrapheneOS team is technically exceptional and has made substantial contributions to Android security that have influenced upstream AOSP development. Both projects deserve support. The question is, which one is right for you? And that question depends on your threat model, your technical comfort level, and how you weigh the trade-off between usability and the depth of the security boundary. My recommendation, if your threat model is serious, is GrapheneOS. If your threat model is moderate and your usability requirements are high, CalyxOS is defensible. If your threat model is serious and you believe CalyxOS is equivalent to GrapheneOS in security terms, that belief is not supported by the architecture, and you should reconsider. The disagreement between the two projects is not a personality conflict. It is a substantive engineering disagreement about how to balance competing requirements, and understanding that substance is how you make a decision that actually serves your needs rather than picking a team based on community vibes. Look at the architecture. Read the documentation from both projects. Decide with your actual threat model in hand. That is the path to an informed choice, and the choice is yours.